Hello everyone, my name is Bastien Sanglard and I will present to you today a part of my work as a postdoctoral researcher in the UST Marseille, which is about the preliminary comparison of Scheffler concentrators for solar cooking. This work is realized in collaboration with the University of Malaga in the person of Xavier Apaolaza-Pagoaga and Antonio Carrillo-Andrés, and with my colleague here in Marseille, Thomas Fasquelle, Séverine Barbosa, and Benjamin Kadoch. So first of all, the context of our work is about the comparison between two different Scheffler concentrators in two different cities in the simplest configuration to cook. And the comparison is based on the standard test method. So first of all, the installation, which is the same in both cases, is composed of the Scheffler concentrator. It's also composed of a secondary installation, which is itself composed of a perforated plate, under which we placed a flat rectangular secondary reflector, and on which we placed a cooking pot containing a certain quantity of water. It is important to note that the flat rectangular secondary reflector is tilt. This is the simplest configuration because it allows the concentrated solar beam leaving the Scheffler to be directly reflected on the bottom surface of the pot. The specificity of the two installations start with the location. Indeed, the first one is located in Malaga with the latitude of 36.7 degrees north and looks like this. It is composed of a Scheffler made of aluminum sheets and with a surface of 2.5 meters square. And in the pot, there is 8.4 kilogram of water. In Marseille, the latitude is 43.3 degrees north and the installation looks like this. It is very different because the Scheffler is much bigger with 8 meters squares of surface, and the reflector surface is made of mirrors facets instead of aluminum sheets. Additionally, in the pot, we have 27.2 kilograms of water. The big difference between the two quantities of water is because of the requirements of the standard test method. Indeed, it is asked that for the test, 4 kilograms of water are used per meter square of maximal aperture area of the solar cooker. So in our case, because we have a much bigger Scheffler in Marseille, we need more water. Additionally, there is another difference, which is the inclination of the secondary reflector. In Malaga, it is 14 degrees, and in Marseille, it's 8 degrees, and this is due to the difference in the latitude. Then the standard test. The standard test is a very well-known method based on the norm ASAE S580.1, and we used it with correction. Basically, the norm gives us access to this indicator, which is the standardized power, as defined as in the equation here. But at the beginning, it was standardized by the global normal irradiation of 1000. But because the Scheffler concentrator concentrate on only the direct normal irradiation, we decided to use a more real value of 850 watt, which is a good weather in Malaga and in Marseille. We also use a standardized temperature difference, which is one of the correction of the norm, and it is standardized with the same value for the irradiation and is defined as the difference between the watt temperature of the water in the pot and the ambient temperature. And this is calculated for intervals of 5 minutes during all the tests. The result can be visualized in two ways. The first one is the plot of the standardized power as a function of the standardized temperature difference. And we can also calculate an indicator when the standardized temperature difference is equal to 50 degrees Celsius. So for the reference case, the reference case means that the bottom surface of the pot is as when it is bought. So it is made of reflective stainless steel. Here we have the evolution of the standardized power as a function of the standardized temperature difference in red for Malaga and in blue for Marseille. Here you have the two equations for the linear regression that are plotted in dots. The first thing that you can see is that for the standardized temperature difference equal to 0, so at the beginning of the experiment, we have a much higher power in Marseille because of the bigger installation. However, what we saw is that the difference between the two Scheffler is of a factor of 3.3, but here the difference between the two value of power is only 2.45. This is due to the difference of the reflective surface and to the performance of the Scheffler to concentrate the power. Additionally, we can also see that the linear regression has a bigger slope in Marseille because the pot is bigger, so the losses are also bigger. To have another point of view, we have decided to normalize the previous result by the effective aperture area of the Scheffler when the tests were made. We have to know that I have to say that the tests were made on close date between Marseille and Malaga, all between the month of March and April. So here are the curves, again in red for Malaga and in blue for Marseille. You have the evolution as the function of the standardized temperature difference. What we can see is that the tendency are changed because now when the test begins, so when the difference between the water and the ambient temperature is 0, it is the installation in Malaga that has much more power, and this is due because of a better reflection of the aluminum sheets compared to the mirrors, and because the approximation of the surface in Marseille cannot allow a good concentration of the solar beam as in Malaga. We can also see that in Malaga, the slope of the linear regression is bigger here compared to the one in Marseille. And this is due to the fact that because the quantity of water is required by the norm and not the size of the pot, we have some difference because it is not a linear relation between the quantity of water and the size of the pot, which means that in Marseille we have a bigger quantity of water, but we do not have as much difference with the size of the pot. So for 1 kilogram of water, there is more surface that loses power in Malaga. So what we already did from this comparison is that we tested the pot with an unpainted bottom with a high power, so which showed that the high power with there was a higher power with the aluminum surface because of the better reflection and or a more precise concentration. And we also saw that the larger Scheffler does not compensate the larger loss due to the larger pot in the case of Marseille. We also tried to realize experiment with the painted bottom of the pot, but we have realized this experiment, but we have not treated the data yet. So this is why they are not shown. And the next step will be to try to insulate the pot and the lid, and also to do other implementation like use of an unperforated cooking hob to be close to what we can expect as a big solar cooker, the use of oil instead of water, or the use of curved secondary mirrors, or any idea that you could have. So I would like to thank you for your attention, and we would very much like to hear your question and suggestion about our work. Thank you very much, and do not hesitate for any questions.